Okay, so add to your list of derivative shortcuts, the derivative with respect to x of natural log x is 1 over x. And let me mention that, remember we said the domain of the natural log function is the positives. You can't take the natural log of a negative. So it's understood when you write derivative with respect to x of natural log x is 1 over x. It's understood that that x is positive. Because again, the graph of the natural log function looks like this. It doesn't touch the y-axis, so x can't be 0. Doesn't go over here into quadrants 2 and 3, so x can't be negative. Okay, I want everybody to take a minute and write the chain rule version of this derivative shortcut. I want everybody to write the chain rule version of this derivative shortcut. How do you take a derivative shortcut and get the chain rule version? You replace x with f of x. Now you've got a composite function. The outside function is natural log. The inside function is f of x. This says the derivative of the outside is just 1 over whatever you're taking the natural log of. So the derivative of the outside is 1 over f of x. But chain rule says I've got to multiply by the derivative of the inside, so f prime of x. So this is the chain rule version of that derivative shortcut. And in your book, this is on page 219, where it says derivative with respect to x of natural log of g of x is g prime of x over g of x. Well, I would say it's 1 over g of x times g prime of x. But notice, you can rewrite that as g prime of x over g of x. Okay, let's do some examples. Let's start down here at the bottom. Derivative with respect to x of natural log of x squared. That's a composite function. The outside is squared function, so I use power rule. Derivative of the outside is 2 natural log x. But I've got to multiply by the derivative of the inside. So I've got to multiply by the derivative of natural log x. So I get 2 natural log x times 1 over x, or 2 natural log x over x. Again, you've got to look to see, do I have a composite function? Yes, so I've got to use chain rule. What's the outside and what's the inside? Don't hone down in on that natural log. Look at the structure of the problem. What's the outside function? It's something squared. So, derivative of the outside, use power rule, then multiply by the derivative of the inside. All right, back up to the top. Derivative with respect to x of natural log of 2x. The outside is the natural log function. The derivative is just the reciprocal. I've got to multiply by the derivative with respect to x of the inside function. So I get 2 over 2x, which is just 1 over x. How about the derivative with respect to x of x squared times natural log of 3x? Well, that's a product. So I've got to use product rule. It's the first times the derivative of the second plus the second times the derivative of the first. I'm going to write my roadmap so I don't make mistakes as I go along by doing too many steps at once. The derivative of natural log of 3x. The outside function is the natural log. Its derivative is just the reciprocal. I mean, isn't that what that's saying up here? Derivative with respect to x, the natural log x is 1 over x. Derivative of a natural log function is just the reciprocal. So derivative with respect to x, natural log 3x. Derivative of the outside, derivative of the natural log is just the reciprocal. I've got 1 over 3x, and I got to multiply by the derivative with respect to x of 3x, derivative of the inside. Plus natural log 3x, derivative with respect to x of x squared is 2x. So I've got x squared times 1 over 3x, x squared over 3x, times derivative with respect to x of 3x is 3, plus, let's just write our 2x out front. We typically write simpler things out front. We don't want this 2x to get connected up with the 3x and get 6x squared. That doesn't make sense. Okay, so I've got 3x squared over 3x plus 2x natural log 3x. That's just x plus 2x natural log of 3x. X plus 2x times natural log of 3x. Why don't you work on these next two? Derivative with respect to x of natural log of x times sine x quantity squared, and derivative with respect to x of 1 over natural log x. And I'll give you an opportunity to check your work. But work on these. Remember, the only way we can get good at this is practice. Again, if you're struggling with this, we've got virtual office hours.